All right, so this is our first lesson in chapter 11. We actually jumped to 11.6. We're going to cover this in 2 days. The first day, we're just going to focus on using our properties with radical expressions, but just with numbers, and then we'll do another day where we're looking at variables. So here we go. All right, before we get to the actual lesson, we need to know about our perfect squares. We've talked about these numbers before, and we're going to use these a lot this entire chapter. So you just want to have this list handy, maybe just at the start of the chapter, so that you can look back anytime we need to know what perfect square numbers we can use. So your perfect squares are numbers that have been squared. So 1 squared is equal to 1. 2 squared is 4. 3 squared is 9. 16, and you just want to go ahead and fill in every single square. I'm going to pause and just fill it in, and then we're going to come back to this list anytime we need it. All right, so there's our list of perfect square numbers. So we're going to move on, and then you'll see how we'll be using these numbers to help us simplify some radical expressions. All right, so first thing we're going to do is reduce some radicals, so it might be helpful to know what is a radical. You guys know them as square roots. This is the square root of 50, this is the square root of 80. This symbol is called a radical, and the reason why it has a more generic term than square root is because when you get into algebra 2, you're going to know, or you're going to learn, that you can do more than take a square root. You can take a third root of a number, you can take a fourth root, a fifth root, a sixth root. A square root is actually a second root. And so instead of always calling this symbol a square root symbol, we call it a radical because that means you could be taking any roots. All right, so to reduce a radical, there is a property in math that lets us take the square root of 50 and break it down into 2 square root numbers that multiply to give us 50. So basically all we're looking at is the 50 and saying what numbers multiply to 50. Now here's the key. You want the first number you pick to be one of those perfect square numbers we wrote down on the last slide. So if you look at the list, you're going to see that 25 fits in to 50. And how many times does it fit in? 25 fits in twice. So you can see we have 25 times 2 gives us 50. So the square root of 50 breaks down into the square root of 25 times the square root of 2. So why did we want to pick this 25 from that list? Why is that so important? That's so that we can do our next step and say, well, what is the square root of 25? That is equal to 5. And then the square root of 2, we can't reduce any further, so that stays as the square root of 2. And that is a reduced radical. All right, so again, you're reducing a radical. You're going to break it down into 2 square roots, but you focus on the first one. The first one you pick has to come from your list. Now, if you look at the list, and maybe I'll do this over here a little bit. Let's say that we have the square root of 80, and the first number you see is a 4. And you say, oh yeah, 4 fits in 20 times. And then you get 2, square root of 4 is 2, and then you've got the square root of 20. Well, it's kind of like taking out a GCF or reducing a fraction completely. Same idea is we want to make sure that we pick, I guess it's more like a GCF, we want to make sure we pick the biggest perfect square number that fits into 80. How do you know if you've picked the biggest number? Look at the one that you're left with, square root of 20. Do any perfect squares fit into 20? And you'd say, oh yeah, that's 4 times 5. And we can take the square root of 4, which means 20 was not the biggest number. So we'll work more on that, making sure we find the biggest number. So we don't want to use a 4. And if you go through your list, does 80 divide by 4? Does it divide by 9? Does it divide by 16? You'll say, yeah, 16 goes in 5 times. So square root of 80 breaks down into square root of 16 times the square root of 5. Did we pick the biggest perfect square? Well, look at the leftover number, the 5. Do any of your perfect squares fit into 5? And no, they do not. I think 1 is on our list, but 1 doesn't ever help us out, so we just kind of ignore it. All right, so the square root of 16 is 4, and the square root of 5 stays as the square root of 5, and that is our reduced radical. All right, so we're going to do some multiplying, and I have more of these in here because your follow-up video does not have any multiplying in it. So we're going to do all those examples in our intro. So there's a property in math that says if you're multiplying two square roots, you can go ahead and put your square roots together or your radicals together and multiply them and say that the square root of 5 times the square root of 8 is equal to the square root of 40. So that was easy. And then just like, you know, getting a fraction, you want to make sure it's reduced all the way. So can we reduce the square root of 40? So you look at your list and you say, do we have any perfect squares that fit in? And we're going to break it down into 4 fits in 10 times. So we have 4 times 10. And just to check, look at your other number, the square root of 10. Do any perfect squares fit into 10? No, they do not. So our final answer, the square root of 4 becomes a 2, and the square root of 10 stays, and that is our answer. So we multiplied them first and got the square root of 40, and then we just had to reduce our answer. So see, these are kind of fun. All right, next, square root of 12 times the square root of 3. Go ahead and multiply the 12 times 3, and we get the square root of 36. Now, do any of our perfect square numbers fit in, or do we already know the square root of 36? And in this case, yeah, 36 is a perfect square number. Take the square root of it, and you get just a 6. So that one's already done. All right, our next example, we have square root of 10 times the square root of 6. Multiply those together, and you get the square root of 60. There's the 0. All right. Now see if you can reduce it. Do any perfect square numbers fit in? And you can just use your calculator and start dividing. Make sure you pick the biggest one. 4 fits in, and again, how do you know that 4 is the biggest number? Look at how many times 4 fits into 60. It fits in 15 times. Do any perfect squares fit into 15? No, they do not. So our final answer is the square root of 4 becomes a 2. And the 15 stays, so you have 2 square roots of 15. All right, our next one, we're going to take square root of 8 times the square root of 14. So we'll go ahead and multiply the 8 and the 14 together, and we're going to get the square root of 112. And then you want to take 112 and see if any perfect square numbers fit into it. So first, if you divide it by 4, you get a 4 and a 28. So is 4 the biggest square, the biggest perfect square that fits in? Look at the other number, 28. Do any perfect square numbers fit into 28? Well, yeah, 4 does. So that just tells us that there's a number bigger than 4. So then take the next one, divide it by 9. Now 112 divided by 9, or if you 9 goes in, but it's like 12.4 repeating, so you don't want any decimals. So you just keep going until you find the one that works. And actually, it's the next one that works out. 112, you can break down into 16 is our perfect square, and it fits in 7 times. And again, just double check, do any perfect squares fit into our other number of 7? No, they do not. So that means that this is going to be our most reduced answer. The square root of 16 becomes a 4, and the square root of 7 stays. All right, here's our last answer. We can also do some division with radicals. So first thing you want to see if you can do is, if you're taking the square root of a fraction, can you reduce the fraction, what's underneath the square root? In this case, yeah, 50 divides by 2, and you get a 25. So we're looking at the square root of 25, and that's kind of nice because we know that the square root of 25 is 5. So that one's simplified right away. All right, now we have the square root of 25 over 16. 25 over 16 does not reduce. So if it doesn't reduce, we actually saw this in our last chapter, you can go ahead and take the square root of these numbers separately. Square root at the top, square root at the bottom. Square root of 25 is 5, and the square root of 16 is 4, and you get 5 over 4. Now, do you remember last chapter when we had a lot of plus or minuses in our answers after square rooting? That was when we were solving an equation for x. We're actually not solving anything. We're just simplifying an existing answer. So we have our answer, just simplify it. It doesn't get the plus or minus like we got last chapter. All right, so next, the square root of 120 over 6. So first see if the 120 will divide by the 6. And that does, we get the square root of 20. Now we want to try to reduce this answer. So look at your perfect square numbers. Do any of those fit into 20? And 4 fits in 5 times. And 5 cannot be reduced any further, so we know we picked the biggest one. Square root of 4 is 2, and the square root of 5 stays, so that became 2 square roots of 5. All right, our last one over here. Can we reduce 135 over 5? Yep, we can. That actually divides nicely into 27. And now we want to see if we can reduce the square root of 27. So look at your list. Do any perfect square numbers fit into 27? And 9 fits in 3 times. And again, look at that 3. Can't fit any perfect squares in there, so we picked the right number. Square root of 9 is 3, and then the square root of 3 stays. And that's our final answer.